Alright, in these examples, I want to go over how to find a solution of the system of linear equations, aka the linear system of equations, by the process of elimination. Now, the solution to a linear system of equations is basically the point of intersection of two straight lines. So we just have to find the x and y coordinate of this point of intersection for these two systems of equations. So the first example, we have 2x minus y equals 1 and 4x plus y equals 8. When we want to use the technique of elimination, we basically try to eliminate either both of the y's or both of the x. The way to determine whether we should eliminate the x or the y has a lot to do with comparing the coefficients of both of the variables. So in this case, for both of the x, they have the coefficient 2, 4, and for the two y's, we have the coefficient of -1 and +1. And as usual, any variable by itself is the same as itself multiplying the invisible 1 or -1. Now, when I compare them vertically, I see that the coefficients -1 and the coefficient +1 are the opposite of each other. So if I add these two equations vertically, I get to cancel out the y. So -1y plus y, hey, that's just going to be 0y. And adding vertically the other two the other two things of each equation, 2x plus 4x is going to be positive 6x, and then this is what plus, and then equal 9. But hey, anything multiplying 0 is going to be 0. So we basically have just 6x equal to 9. And to find the x coordinate, divide both sides by x. By 6. Yeah, x equals 9 over 6, plus 9 over 6 can be simplified out to 3 over 2. So that's the x coordinate of the solution. Now to find the y coordinate of the solution, all we have to do is that we take the x values that we found and we plug it back into one of these equations. I want to pick the second one because it's easier and because we already have the positive y here. So it makes it easier so that I don't have to divide both sides by the -1. So I got 4 times x, but x is 3 over 2. So we got 4 times 3 over 2 plus y equal to 8. Cancel out the common terms 2, and 4 is reduced down to 2. You got 2 times 3, that's 6, plus y equal to 8. Solve for y by subtracting 6 to both sides. And guess what? You got y equal 2. So the solution is 3 over 2, comma 2. All right, next example number 2. You got 3x plus 5y equal -3. And you got -5y plus x equal to -5. Now, in this example, you can tell that one equation has the standard form order and the other equation has the x and y switching places. So to compare them, we want to make sure that we line them up accordingly. So 3x plus 5y equal to -3. And for the second one, I'm just going to switch places so that the x is on top of the other one. So x and x. And for the y, I got minus 5y equal to -5. Well, you see? Now with these two equations, guess what? I can cancel out the y again because the coefficients of both of these y are +5 and -5, which are opposite of each other. So if I add these two equations vertically, you got 5y minus 5y, that's going to be 0y, and then equal to -8 on the right. And then 3x plus x is going to be +4x. Anything multiplying 0 is going to be 0. So we left with just 4x equal -8. Solve for x by dividing both sides by 4 because we're multiplying. So we got x equals -2. Now with one variable already known, take its value, plug it back into one of these equations, and solve for the other one. So I'm going to plug it back into the first one now. So with x equal -2, I'm going to bring down the first equation. I got 3 times x, which is -2, plus 5y equal to -3. Positive 3 times -2 is -6, plus 5y equal to -3. Get closer to the y by first eliminating the -6 and then the multiplying plus 5. By adding 6 to both sides, I got positive 5y equal to positive 3. We're going to solve for y by dividing both sides by 5. I got y equal to 3 over 5. So hey, the x and the y coordinate of the solution of this system is -2, 3 over 5.